So just like we were able to draw a parallel between two-digit multiplication and multiplying polynomials, we can do the same thing for dividing them with standard long division. So let's refresh on how to do standard long division. So first we're going to be dividing 5 into 200, or 200 divided by 5. We look if 5 can go into the first term, which it can't. It goes into 2 0 times. So we look at the next two terms together. 5 goes into 20 4 times, and we multiply these two things and subtract them. We multiply our quotient and our divisor, and we get 20, and we're going to subtract that from the two numbers we subtracted from. So that'll give us 0, and the moment we get 0, we bring down our next term, which is also 0, so this is still 0. And we divide that again. 5 goes into 0 0 times. 0 times 5 is 0, so we subtract 0, and we get 0. And there's nothing else to bring down, so our remainder here is 0. So this is 40 plus 0 fifths. The remainder is 0 fifths, which is the same thing as just saying 40. But there's often going to be some really strange remainders when it comes to actually dividing polynomials, so it's good to see what they look like as numerical examples. So let's go take a look at one of those polynomial examples. Alright, so we're going to do the same thing. We're going to use long division to find the quotient and remainder. We're going to divide this cubic equation by this linear equation. It's linear because this has a highest degree term of 1. This is cubic because there's a highest degree term of 3. And I know that these can divide into each other evenly because I created it that way. I multiplied x plus 3 with two other binomials, and I came up with this cubic polynomial. Specifically, what we're going to get is this, with no remainder, because this times this equals this. So that means this divided by this should be this, and this divided by this should be that. So we know what the factors of this are, so we can actually check that, assuming that I created this correctly, which I believe I did. So it works the same way. We're only going to focus on this first term, though. So this is where our focus is. We don't care so much about that. This 3 is not going to be that important. Alright? So, we're going to start dividing from the largest side first, just like you do at long division. X goes into 2x to the third, 2x to the second times. And then I'm sure you're saying, that's kind of random. That's because 2x to the third divided by x is 2x to the second. Anything just divided by x is going to have one less power. And now we're going to do what we did previously. We're going to multiply these terms and subtract it from here. So if we multiply this, we're going to subtract it. 2x squared times x is 2x to the third. And we're not just subtracting that, we also have to subtract this. 2x squared times 3, which is positive 6x squared. Alright, so we're going to subtract, and then we're going to bring down this negative 11, just like you would normally. I'm going to change the color now. Maybe it'll become a little clearer. So 2x to the third minus 2x to the third is 0, and 3x squared minus 6x squared is minus 3x squared. Bring down the 11x. It's actually negative 11x, which is important not to miss things. I miss them all the time. I have to go back and fix them. Alright, so we do the same thing. X goes into negative 3x squared, negative 3x times. We do the same thing as we did before. We're going to subtract it when we multiply it with x to the third. So it's minus 3x squared. Negative 3x times positive 3 is negative 9x. Okay, let's change colors again. Let's use yellow, I think. Alright, so these are going to cancel out, because 3x minus itself will be 0. 11 minus minus 9 is actually negative 2 in this case. Bring down the negative 6. And let's do this again. X goes into negative 2x. Negative 2 times. We multiply these and subtract. We'll get negative 2x minus 6, which is the same thing. Anything minus itself is 0. So it has a remainder of 0. So our final answer should be this. 2x squared minus 3x minus 2 plus 0 over x plus 3. Do we need to write this? No. This would be fine as our answer. Why did I write this? Because when it does have a remainder, you would write this. So I want you to get used to seeing what your answers should look like earlier. Alright? So let's look at a numerical example that actually leads to a remainder and see how you represent that. Okay. I went the wrong direction. Okay, so 6 into 200. 5 we know goes into 200 evenly, but 6 does not. Alright, so let's work it through. 6 goes into 23 times. Again, it didn't go into 2, so I just went straight to 20. So we're going to take away 18. We get 2 left over. Bring down the 0. It goes into 6. 6 goes into 23 times again. And that'll be 18. We subtract that. We get 2 again. So our remainder is 2. So this is 33 and 2 sixths, which simplifies to be 33 plus 1/3, or just 33 and a third. And what's interesting is if you were to add a decimal and some zeros here, you could just keep going here, bring down the 0, divide that in here, you'll get 0.3333 forever, and that's where the 1/3 comes from. Okay, and we've discussed how to turn these repeating decimals into fractions before, so if you wanted, you could do it that way. I wouldn't. That would be more complicated than necessary. So let's take a look at a polynomial example that leads to a remainder. This is the same one, the same example as before, this trinomial that I created, and this time we're going to divide it by x plus 5. And this should lead to a remainder, and I know that because none of the factors of 2x to the third plus 3x squared minus 11x minus 6 are x plus 5. So it doesn't go into them evenly. So I'm going to scroll down for more space, and we're just going to perform the long division. So again, we're focusing mainly here. We can ignore that for now, and we're going to look at how many times it goes in here. So x goes into 2x to the third, 2x squared times, again that's just this divided by this, or you could think of it as, what do I need to multiply this by, x by, to get this, same kind of idea. We multiply these and we'll subtract. That's 2x to the third minus 10x to the second. And we will subtract. Let's change colors. That cancels out. 2x to the third minus 2x to the third is 0. 3x to the second minus 10x will be positive 13x squared. Okay, x goes into 13x squared. 13x times, I forgot to bring down the 11. Bring down the 11. Okay, so now we multiply. 13 times x would be 13x squared. I'm already subtracting this. 13x times 5 is, I want to say 65x, positive 65x. Okay. No, I made a mistake somewhere. Hold on, I gotta go back. I apologize. Start that one more time. So sorry. X goes in here, 2x to 2x squared. This multiplies and is 2x to the third plus 10x squared. I thought something looked weird. This is supposed to be positive. So those cancel out. That's going to be negative 7x squared, which will make a huge difference. Bring this down. And now we do the same thing. X goes into negative 7x squared, negative 7x times. Now we multiply and subtract. Negative 7x squared. Negative 37 goes multiplies by positive 5 to get negative 35. Let's change colors. Okay. This is going to cancel out. And negative 11 minus 35 is positive 24x. I left out the x here. Okay, bring down the minus 6. And now x goes into 24x 24 times. 24 times x is 24x. As you've noticed, the first terms have been the same each time. And 24 times 5 is 20 times 5 is 100, 120. Okay. So those cancel out. 6 minus 120 is minus 126, which is a pretty big remainder. So our final answer should be, let's put that in orange, that should be 2x to the second minus 7x plus 24, with a remainder of negative 126 x plus 5s. Okay, so that's long division, and it is highly unpleasant, but it is the way to do it. And we'll be looking at synthetic division tomorrow, which is a shortcut method of doing it, which is much easier if you can remember how to do it. So I'll show you that tomorrow.